Welcome to the Ultimate Spring Boot course. In this course, you'll learn everything you need to know from the basics to more advanced concepts, so by the end, you'll be able to build real-world applications with confidence. If you're looking for a comprehensive, easy-to-follow, well-structured, and practical course that takes you from zero to hero, this is the Spring Boot course for you. I've organized this course in two parts. The first part, which you're watching now, covers the fundamental concepts, and the second part focuses on building web applications and APIs. The course is packed with hands-on examples and real-world exercises to help you truly absorb and apply what you learn. I've poured my heart and soul into creating this course, and I'm confident it will be a game changer for your skills. I'm Mosh, a software engineer with over 20 years of experience, and I've taught millions how to code and become professional software engineers through my YouTube channel and online school, codewithmosh.com. If you're new here, make sure to subscribe as I upload new videos all the time. So, if you're ready to master Spring Boot and build applications with confidence, let's jump in and get started. To get the most out of this course, you should have a solid understanding of Java. You should be comfortable with object-oriented programming, working with classes, methods, and interfaces. If you're new to Java or need a refresher, I recommend going through my Java course before starting this one. I'll put the link down below. You should also be familiar with relational databases and SQL. You should know concepts like tables, primary keys, foreign keys, and writing basic queries. If this sounds new to you or you want to strengthen your SQL skills, check out my SQL course where I cover everything from the basics to more advanced queries. That's all you need to get started. If you already meet these prerequisites, you're good to go. Otherwise, take some time to review Java and SQL before jumping in. Now let's move on to the next lesson. Before we dive in, let's talk about how I've structured this course so you know what to expect and how to get the most out of it. This course is divided into two parts. The first part, which you're watching now, covers the fundamentals of Spring Boot. The second part will focus on building web applications and APIs. In the first part, we'll go step by step to build a strong foundation so that when we move on to building applications, you will have all the essential skills you need. Part 1 is divided into 3 sections. We'll begin by understanding what Spring Boot is and why it's such a powerful framework. We'll also set up our development environment and build our first Spring Boot project so we can get a feel for how everything works. Then we have Dependency Injection. In this section, you will learn how Spring Boot manages objects and their dependencies behind the scenes, making our applications more modular, testable, and maintainable. In the next section, we talk about database integration with Spring Data JPA. This is the bread and butter of part 1. We cover concepts that are often overlooked in other courses. You will learn best practices, efficient data access patterns, and tools that are essential for building real-world applications. To get the most out of this course, watch every lesson in sequence. I cover a lot of details that build on previous concepts, so skipping around might cause you to miss something important. This course is also packed with exercises to reinforce what you learn. I strongly encourage you to complete each exercise before watching my solution. Struggling a bit before seeing the answer will help you retain the concepts much better. Now that you know how the course is structured, let's move on to the next lesson. As you go through the course, you'll often want to check out the exact code I write in each lesson. So to make it easy for you to follow along, I've organized the source code using a GitHub repository that you can find at github.com/moshhamedani/springstore. Now, technically, you don't need to know Git to take this course, but Git is one of those skills that every developer must have. If you want to dive deep and truly master Git, I have a complete Git course on my website where I teach everything from the fundamentals to advanced workflows. You can find it on codewithmosh.com. Now, back to our repository. In this repository, each commit represents a lesson. So if you want to see the exact code I write in this lesson, just click here and you can see the changes. Also, I've created tags for the beginning of each section. For example, if you want to start from part 1, section 4, you can use this tag. It's not something that I recommend unless you're an advanced student because there is so much that we're going to cover in this course, and ideally, you should watch every lesson in order. So that's all about our Git repository. Let's move on and continue learning. Welcome to the first section of the course. In this section, we'll take our first steps with Spring Boot. We'll start by learning what Spring Boot is and why it's so popular among Java developers. Next, we'll get our development environment set up and create our first Spring Boot project. I'll walk you through the project structure so you understand how everything is organized. From there, we'll dive into dependency management, then build and run our first Spring Boot application. We'll also cover some essential tools like Spring Boot DevTools that make development faster and easier. You will learn how to configure your app with properties and how to debug it when things go wrong. By the end of this section, you'll be comfortable setting up and running Spring Boot projects, and you will have your first application up and running. Now let's get started. Before we jump into writing code, let's take a few minutes and talk about what Spring Framework is, what it offers, and how Spring Boot builds on it to make our lives easier. Let's start with the Spring Framework. It's a popular framework for building Java applications. Think of it as a toolbox for building applications. It has a lot of modules, each designed to handle a specific task. These modules are broadly categorized into a few different layers. At the core, we have modules for handling dependency injection and managing objects. We'll talk about that in detail in the next section. In the web layer, we have modules for building web applications. With these modules, we can handle web requests, process data, and return responses, whether it's HTML for a web page or JSON for an API. In the data layer, we have modules for working with databases, whether you're using SQL, NoSQL, or even in-memory databases. We also have a module for adding cross-cutting features like logging or security without cluttering the main code. This is called AOP, or Aspect-Oriented Programming. We also have a module for testing of Spring components. Now, the beauty of Spring is that it's modular, so you can pick and choose the modules you need for your project. It's powerful and flexible, which is why so many developers love it. Now, while the Spring framework is powerful, using it often involves a lot of configuration. For example, if you want to build a web application, you might need to set up a web server, configure routing, and manage dependencies manually. This can make development slower and more complex. That's where Spring Boot comes in. Think of Spring Boot as a layer on top of the Spring framework that takes care of all the tedious setup for you. It simplifies Spring development by providing sensible defaults and ready-to-use features. So why does this matter? With Spring Boot, you can go from idea to working application in minutes instead of hours. It saves you time, reduces boilerplate code, and lets you focus on what really matters, building great features for your users. By the way, the Spring framework is just one part of a larger family of projects in the Spring ecosystem. These projects extend the capabilities of the framework to address specific needs. For example, we have Spring Data for simplifying database access. We have Spring Security for adding authentication and authorization to our applications. We have Spring Batch for batch processing, Spring Cloud for building microservices and distributed systems. We have Spring Integration for simplifying messaging and integration between systems and more. Now that you understand what the Spring Framework and Spring Boot are and how they fit in the larger Spring ecosystem, let's start building. Before we start building applications with Spring Boot, we need to get our development environment ready. First, you need the latest version of the Java Development Kit, or JDK. So open up your browser and search for Download JDK. You can find it on oracle.com. Now, at the time of this video, the latest version is JDK 23. It is possible that in the future, when you're watching this video, there is a newer version of JDK available. That's not going to make this course outdated, because what I'm going to teach you in this course will apply to future versions of JDK as well. So download the latest version of JDK here. As you can see, there are distributions for different operating systems, Linux, macOS, and Windows. Once you download and install the latest version of JDK, open up your terminal window and run java-version to verify that the JDK is installed correctly. So as you can see on this machine, I'm running JDK version 23. Next, we need a code editor. In this course, I'll be using IntelliJ IDEA. That's the most popular IDE for professional Java and Kotlin development. IntelliJ IDEA comes with a variety of built-in tools specifically designed for productive development with Spring Boot. You can also consider alternatives like VS Code or Eclipse. I personally love IntelliJ IDEA, especially because of its smart editor. It not only auto-completes method names, but also suggests entire chunks of code that you can insert with a single press of tab. You'll see me doing that throughout the course. This makes it much easier to write high-quality code faster without getting stuck on syntax or boilerplate. I highly recommend using IntelliJ IDEA for this course because it simplifies your workflow and helps you focus on learning Spring Boot instead of dealing with setup issues. And here is something great. Thanks to JetBrains, the creators of powerful IDEs, plugins, and services, you can try IntelliJ IDEA Ultimate free for 3 months using the link and promo code below this video. Now, the next step is installing a build automation tool for building and packaging our application. Here we have two options, Maven and Gradle. Different people have different preferences, but in this course, we'll be using Maven because it's more popular. Now, if you're using IntelliJ, you don't need to install Maven separately because IntelliJ has Maven built in. That's one of the reasons I said IntelliJ makes it much easier to get started. It comes with all the tools you need to build Spring Boot applications. But otherwise, if you're using VS Code or Eclipse, you'll have to install Maven separately. You can download Maven from maven.apache.org. Now, if you're on a Mac, you can install Maven with Homebrew. It's much easier. So open up your terminal, first run brew update, and then run brew install Maven. It's much easier to install it this way. If you're on Windows, I recommend installing Maven using Chocolatey. In case you are not familiar with it, it's a package manager for Windows. So first head over to chocolatey.org, download and install Chocolatey, then open your terminal window and run choco install Maven. Now, once you're done, to verify that Maven is installed properly, run mvn-v. So on this machine, I'm running Apache Maven 3.9. Now, there are two ways to create a new Spring Boot project. One way is to go to start.spring.io. On this page, we can select a few options and generate a new Spring Boot project. So first, we specify our build tool, which can be Gradle or Maven. By default, Maven is selected, so we keep it as is. Next, we select our language, which is Java. Then we select the version of Spring Boot. At the time of this course, the latest stable version is 3.4.1. There is a newer version, but that's a snapshot version, so it has experimental features that might be removed in the future. So make sure to select the latest stable version. Now, under project metadata, we have group, which is the group or organization that owns this project. By convention, we use a reverse domain name. So example.com becomes com.example. Now, in my case, I'm going to change this to code with Mosh. Next, we have artifact, which is the name of the project. I'm going to change that to store because we're going to build an online store in this course. Now, name is the same, so whenever we change artifact, name gets updated as well. We can leave description as is. Now, package name is the combination of the group and artifact. Again, we're not going to touch this. Next, we have the package type, which can be jar or var. We're going to use jar. And then we specify the Java version. In this course, we'll be using Java 23. Next, we can select our dependencies. These are third-party libraries or frameworks we're going to use in our project. We'll talk about these later in the section. Next, we go ahead and click Generate. Now, this gives us a zip file. Once you unpack it, you can open it with your favorite editor. But again, I recommend you to use IntelliJ because when using IntelliJ, we don't even have to go to this website to create a new Spring Boot project. We can create a project right inside of IntelliJ. So open IntelliJ and click New Project. Now, on the left side, under Generators, select Spring Boot. Now, what you see on the right side is exactly what you saw earlier on start.spring.io. Now, I need to highlight that this feature is only available in IntelliJ IDEA Ultimate Edition. If you're using the Community Edition, which I don't recommend, you won't see this feature. The Community Edition is quite limited in terms of features, so if you want to do professional development, you should use the Ultimate Edition. So first, we specify our project name. I'm going to change this to store. Next, we specify the location. You can put it anywhere you want on your machine. It doesn't matter. Now, optionally, we can create a Git repository. I recommend you to do this so you can properly version your code. Next, we specify our language, Java, our build tool, Maven, our group. I'm going to change this to com.code with Mosh. We leave artifact and package name as is. Next, we specify the JDK version. Right here, we have JDK 23. But what is beautiful about IntelliJ is that we can also download the latest version right here. So we don't have to go to our browser to download JDK separately from oracle.com. Okay. Next, we select the Java version. I'm going to change this to 23 and click Next. Now up here, you can see the version of Spring Boot, that is 3.4.1. Optionally, we can select our dependencies. Again, we're going to leave this for now and come back to it later. So let's go ahead and create our first Spring Boot project. All right, now let's talk about our project structure. First, we have this folder, .idea, that contains a bunch of configuration files used by IntelliJ. You never have to touch these. Then we have .mvn. This is part of Maven wrapper, which is a way to run Maven without requiring it to be globally installed on your machine. With this, we can ensure consistent Maven builds across different environments. So we can take this project, put it on a different machine, and build it with the exact same version of Maven. And with this, we can prevent surprises. Let me show you what we have here. So inside this folder, we have the wrapper folder. And in this folder, we have a configuration file that specifies the version of Maven we're going to build this project with. That is 3.3.2. This is different from the Maven you have globally installed on your machine. Now, once again, I want to emphasize, if you use IntelliJ, you don't need to install Maven globally on your machine because IntelliJ comes with Maven built in, okay? So this is our configuration file. Now, in this project, we also have two Maven wrapper files in the root. We have mvnw, which is for Mac or Linux, and mvnw.cmd for Windows. Both of these files are shell scripts. So here we have some code that would automatically download the version of Maven specified in this configuration file, okay? So that's the MVN folder. Then we have a couple of files for our Git repositories. That's pretty standard. We're not going to talk about them in this course. We have help.md, which is a markdown file that contains instructions for getting started. Again, we don't care about it. Next, we have pom.xml. This is short for Project Object Model. And this is the heart of a Maven project. So in this file, we have some configuration about our project and its dependencies. Now, what you see here is a format called XML, which a lot of younger developers are not familiar with. It's similar to HTML. So here we have open and close tags. And in between these tags, we have some data. So here we have all the attributes we specified at the time of creating our project. We have group ID, artifact ID. This is the version of our project and so on. Further down below, we have a tag called dependencies, which we're going to talk about later in this section. So pom.xml is the heart of Maven projects. Maven uses this file to download dependencies and build our project. Now, back to our project structure. In the source folder, we have the actual code for our project. We have main and test. In the test folder, we write our automated tests. In the main folder, we write the actual code. Here we have two subfolders, Java, where we have our Java files, and resources, where we have non-Java files, like configuration files, as well as static assets like HTML, CSS, JavaScript, and so on. In the resources folder, we have a configuration file called application.properties. Here we can have one or more key value pairs. So here is a key, spring.application.name, and the value is stored. In this file, we can specify the server port, our database settings, and so on. Now, here in the Java folder, we have a package based on the group and artifact we specified when creating this project. In this package, we currently have one file, store application, which is the entry point to our application. So here we have a Java class, and inside this class, we have our familiar main method. In this method, we have a call to Spring application.run method. So that's the basics of our project structure. Next, we're going to talk about dependency management. Earlier, we talked about dependencies. I told you that dependencies are third-party libraries or frameworks we use in our application. For example, to build a web application, we need an embedded web server like Tomcat. We need libraries for handling web requests, building APIs, processing JSON data, logging, and so on. Now, in Spring Boot applications, instead of adding multiple individual libraries, we can use a starter dependency, which is a curated collection of libraries and frameworks that are commonly used together. They're tested and verified by the Spring development team. So in this example, if we add the starter web dependency, it will bring in a compatible version of these libraries. Let's see this in action. So open up your browser and search for Maven Central. It's right here, central.sonotype.com. Now, Maven Central is a public repository where we can find dependencies for our projects. It's similar to NPM for JavaScript, PyPy for Python, NuGet for .NET, and so on. Now here, let's search for spring-boot-starter-web. All right, here's the first item in the result. This dependency or this project is owned by org.springframework.boot. Now let's click on the dependency name. Now to use this in our project, all we have to do is copy this piece of code in our POM file. Now this piece of code is dependent on our build tool. So up here you can see we have Apache Maven. So for Maven projects, we have to copy this piece of code. But if we use a different build tool like Gradle, then we have to copy a different piece of code, okay? So back to Apache Maven. Now here you can see we have a dependency. The group ID is org.springframework.boot, and the artifact is springboot starter web. We also have the version. Now let's copy this to clipboard. Back to IntelliJ. Let's go to our POM file. Now in this file, we have a tag called dependencies, where we can list the dependencies of our project. This new project that we have created has two dependencies by default. One of them is Spring Boot Starter. The other is Spring Boot Starter Test. Now, after these two dependency tags, we're going to paste the piece of code that we just copied. Now here we have an error on the version because IntelliJ cannot find this dependency in our local repository. It cannot find it on our machine. To fix this issue, we have to click on this M box up here for synchronizing Maven changes. So whenever we add a dependency to our project, we have to click this icon to reload our Maven project. And then IntelliJ will download our new dependencies. So I'm going to click this. Now look down here. It's resolving these dependencies. Okay, the error is gone. So this is one way to add a dependency. We go to Maven Central, we copy a piece of code, add it to our POM file, and then reload our Maven project. That's one way. But there is an easier way. First, let me remove this new dependency. So delete. Now here we can press Command and N on Mac or Control and N on Windows to bring up the context menu. Here we select dependency. Now in this search box, we search for spring-boot-starter-web. Now, if this doesn't work on your machine, remove and reinstall IntelliJ. That will solve the problem, okay? Now here you can see various dependencies that match the search pattern. We're going to select this one from org.springframework.boot. And this is Spring Boot Starter Web version 3.3.2. Let's add this to our project. Once again, we have an error here because this version doesn't exist in our local repository. So we click on the Maven icon here to reload our project. And now IntelliJ downloaded this dependency into our local repository. Now, if you look on the right side, we have this Maven panel. In this panel, we have our project. Here we have a node called repositories. So we have two repositories. A local repository, which is a folder on our machine where these dependencies are stored. On Mac, it's inside our home folder /.m2/repository. On Windows, it's probably somewhere like C drive /users /whatever. Now we also have a central repository which references Maven Central. Okay. Now let's take a look inside the dependencies node. So currently we have 3 dependencies in this project. This is the dependency that we just added, Spring Boot Starter Web. Now earlier I told you that starter dependencies are curated collection of libraries that work together. So if we expand this, you can see here we have another dependency for working with JSON data. We'll talk about this in the future. We have a dependency for Tomcat, which is our embedded web server. We have a dependency to Spring Web and Spring Web MVC. These are used for building web applications. With these libraries, we can process web requests and build APIs. Now, one more thing before we finish this lesson. When working with Spring Boot dependencies, as a best practice, we should remove the version here and let Spring Boot manage versioning for us. Let me explain what I mean. So first, let's remove the version tag. Okay, now let's go to the top. Here on the top, we have this parent tag that references a parent project. Look at the artifact ID. It's Spring Boot, starter, parent. Now, if we hold down the Command key on Mac or Control key on Windows and hover our mouse over here, we can click and go to the POM file of this parent project. So now we are inside a separate POM file. Once again, here we have a parent tag that references a different project, that is Spring Boot dependencies. So once again, hold down Command on Mac or Control on Windows and click here. So here is the actual parent or grandparent of our project. Now, if you're on Mac, press Command and F. If you're on Windows, press Control and F and search for spring-boot-starter-web. Look, here we have a dependency to this package, and the version that is specified here is 3.4.1. Similarly, we have other dependencies and their versions, and these are tested to work together. So back to our POM file. Using this mechanism, we allow the dependencies that we add here inherit their version from this parent project. So if they're listed in the parent project, that version that is compatible with our project will be used here. Otherwise, Maven will use the latest version of those dependencies. Now, this has two benefits. One benefit is that it simplifies our POM file. So down here, where we specify our dependencies, we don't have to include their version. The other benefit is that if we upgrade the version of Spring Boot, all dependency versions are automatically updated to their tested, compatible counterparts. So as a best practice, when working with Spring Boot dependencies, we should remove the version and let Spring Boot manage versions for us. In this lesson, we'll create our first controller to handle requests to the homepage and serve a simple HTML file. But before we start coding, let's take a moment to understand the basics of Spring MVC, which is the foundation of how we handle web requests in Spring Boot. Spring MVC stands for Model View Controller and is part of the Spring framework that helps us build web applications. It provides a clean way to separate different parts of our application, making it easier to manage and scale. Model is where our application's data lives. It represents the business logic and is usually connected to a database or other data sources. In Spring Boot, the model can be a simple Java class. The view is what the user sees. It's the HTML, CSS, or JavaScript that's rendered in the browser. In Spring MVC, views can be static files or dynamically generated using tools like Timeleaf. The controller is like a traffic controller. It handles incoming requests from the user, interacts with the model to get data, and then tells the view what to display. Let's see this in action. So back to our project. Here in the Java folder, inside this package, let's right-click and add a new Java class. We're going to call this Home Controller. Now, IntelliJ is asking if you want to add this to our Git repository. I'm going to select Don't Ask Again, so we don't see this in the future. Let's go ahead and add this to our repository. Okay. Now, to make this a controller, we have to decorate it with the controller annotation. So here we type an @ followed by controller and then press Enter. So this annotation is defined in this package, org.springframework.stereotype. Okay. Now, I believe I covered annotations in my Java course, but very briefly, an annotation is like a label or a tag that we add in the code to give instructions or additional context to the compiler. We can apply them to classes, methods, fields, parameters, and so on. So in this example, by adding this annotation to this class, we are telling Spring that this class should be used as a web controller for receiving web traffic. Now, inside this class, we add a method, public, string, We can call this method anything we want, but I'm going to go with index. Now, when we send a request to the root of our website, we want this method to be called. To do that, we have to apply another special annotation here, that is request mapping. Now, this other annotation is defined in this package, org.springframework.web. This is part of the web starter dependency that we added in the previous lesson, okay? So we add this annotation and then give it an argument. That is a URL pattern. Here we can type a / that represents the root of our website. So when a request goes to the root of our website, this method gets called. If you want to receive traffic at a different endpoint like about or contact, we can change the argument here, okay? So let's go back to the root of our website. Now in this method, we return the name of the view that should be returned to the browser. So we return index.html, okay? Now we need to create this view. Back to our project, we go to the resources folder. This is where we add non-Java files. Now here we add a new folder called static. And inside the static folder, we add a new file, a new HTML file called index.html. Now, in this HTML file, inside the body element, we type h1 tab, and inside the h1 tag, we type hello world. So this is our view. Now, we're not going to cover models in this lesson. We'll cover them later in the course. Next, I'm going to show you how to build and run this application. Hey guys, thanks for sticking with me so far. Just a quick break. If you're enjoying this tutorial, I wanted to let you know that this is just the first hour of my complete Spring Boot course. The full course has 2 parts, with each part being about 6 hours long. It covers a whole lot more, taking you from the basics all the way to advanced concepts. You will learn everything you need to build real-world backends with Spring Boot. So after you watch this tutorial, if you want to learn more and level up your skills, check out the link in the description below and enroll in the complete course. Now, let's jump back in. All right, now let's talk about running our application. If you're using IntelliJ, you can run this application by clicking the play icon on the toolbar. Look at the shortcut. It's Control and R. So I'm going to press that. Our application is built. Now here on the console window, if you scroll to the right, you can see that Tomcat, which is our embedded web server, is initialized with port 8080. So now if you open our browser and navigate to localhost port 8080, we can see our homepage. Beautiful. Now let me show you a different way to run this application. Back to IntelliJ. First, I'm going to stop this. Now, if you're not using IntelliJ, you can run this application using Maven. First, we have to open a terminal window and go to our project folder. I've put this project on my desktop inside springboot/demo/store. So right now, I'm inside the project folder. You can see that in the terminal, I'm on the main branch of my Git repository. So if you run ls on Mac or Linux, or dir on Windows, we should be able to see our project files. So look, earlier we talked about these 2 files, mvnw, that is a Maven wrapper. So if you don't have Maven globally installed on your machine, you can use the Maven wrapper. Now here on Mac or Linux, to run this, we have to type /mvnw. Then we type a space followed by -v. So as you can see, I'm running Maven 3.9.9. Now, if you're using Windows, you have to type mvnw.cmd space -v. Actually, I think .cmd is optional, but I'm not entirely sure. I haven't used Windows for over 10 years, so excuse me if I'm making a mistake here. Anyway, so now with this Maven wrapper, we can run our Spring Boot application. But instead of -v, we're going to type spring-boot:run. Take a look. Maven compiled our application. So now, once again, if we go back to our browser and navigate to this address, we should see our homepage. You have probably seen this guy before in my other courses. His name is John Smith. He's our self-proclaimed rockstar developer who claims he writes bug-free code. According to John, debugging is something other people need to do. But let's be real. Bugs happen to all of us, even if you're as perfect as John Smith thinks he is. So in this lesson, I'm going to show you a few different techniques for debugging your Spring Boot applications. Back to our home controller, let's make a few small changes and introduce a bug. First, let's define a private method that returns a string. We call this getViewName. And here we return index instead of index.html. Now back to our index method. First, we declare a variable called viewName. And here we call getViewName. And then we return viewName. Obviously, this is unnecessary. This code is very redundant, but we are deliberately doing this for the purpose of debugging. Now let's rerun our application. So we press Ctrl and R. IntelliJ is saying that this process is running. It's asking us if we want to stop and restart the web server. Let's go ahead. All right, good. Back to the browser. Let's refresh. All right, now we have an error because there is no view called index. Our view file is index.html. So let's see how we can find this bug. Back to our home controller, the simplest way to debug this application is using a print statement. So before we return the name of the view, we can type system.out.println viewName. Now let's rerun this application. Okay, back to the browser, refresh. Now we go back to IntelliJ. Here on the console window, we can see the output of our print statement. So we are returning index, which is not a valid view name. So this is a simple way we can debug our applications, but we can also use the debugging tools in IntelliJ or other IDEs. To do that, first, let's remove this print statement. All right, now we're going to start our application in the debug mode and execute it line by line. To do that, first we have to insert a breakpoint in our code. A breakpoint is a marker that tells IntelliJ to pause our application when the program reaches that line of code. For example, here we can add a breakpoint by clicking in the left margin. This red dot represents a breakpoint. We can click it again to remove it. So we insert a breakpoint. Now we start the application in the debug mode and the execution stops right here. To do that, instead of clicking the play button, we should click the debug button. Look at the shortcut. It's Ctrl and D. So I press Ctrl and D, rerun our application in the debug mode. Okay, our web server is listening on port 8080. So now we go back to the browser and refresh this page. So our home controller is hit. So refresh. Okay, here we are. And the execution stopped right here on this highlighted line. Now this line is not executed yet. We can execute it line by line using this tool over here, step over. The shortcut is F8. So if we press F8, this line is executed. And now inside this little window, we have the variables that are meaningful in the current context. So we have this, which is a reference to the current object, which is home controller. We also have view name, which is set to index. So using this window, we can verify that our variables have the right values. Now, if a variable is not detected here, we can add an expression here, for example, view name. And here's the result, okay? Now, we don't need this, so let's remove it. So this is how we can use step over. Now, we can step over this line as well. So we press F8. Now we are inside the source code of the Spring framework. Now, this is not the actual source code. This is the decompiled class. But we don't care about this code because this is not part of our application we want to debug, right? So we want to continue execution until something is rendered in the browser. To do that, we have to use a different tool. Look at this button. This is for resuming program. The shortcut on Mac is Option, Command, and R. So I'm going to press these keys. All right. Now all the code has been executed and here is the result. Now back to our home controller. Let's say we haven't found the bug yet. So we want to restart the debugging session. Again, we press Ctrl and D. Now we go back to the browser and refresh this page. So our home controller is hit. But this time Instead of stepping over this line, we're going to step into it. Maybe there is a problem with this method. To do that, we use this button over here, step into. The shortcut is F7. So we press F7, and now we are inside this method. Here we have only a single line of code. We could have tens or hundreds of lines of code, and this method could call other methods. So again, we could step over or step into those lines until we would find the source of the problem. Now, in this case, we know the problem is with the string literal that we are returning. So let's change that to index.html. Now that we're done, we stop the debugger and remove this breakpoint. We don't want to leave these breakpoints all over the code because they're going to get in the way in future debugging sessions. You have noticed that every time we change our code, we have to rebuild our project. But in Spring Boot, we also have the automatic restart feature. It's not ideal, it's not as fast as automatic restart we have in Node or React because there is a little bit of delay. But let me show you how to set it up. First, we have to go to our POM file. Now let me show you a cool shortcut. Here we can press Shift, Command, and O on Mac, or Shift, Control, and O on Windows. Now over here, we can search for our files. So pom.xml. Now here we're going to add a dependency. To do that, we press Command and N on Mac or Control and N on Windows. We select dependency and search for spring-boot-dev tools. Okay, now look at this dependency from org.springframework.boot. So we add this to our project. First, we remove the version because this dependency is part of the Spring framework, so it's better to allow the parent element determine the version of this dependency. So let's delete this line. Instead, we add another tag called optional, and we set it to true. That means this is not part of our application code. It's not going to be packaged with our application to be deployed into production. It's only used during development, okay? Now, we have an error because this dependency does not exist in our local Maven repository. So we have to click this button to reload our project. Now Maven downloaded this dependency, good. Now to use this in IntelliJ, there are two settings we have to modify. We go to the top under IntelliJ IDEA menu. We go to settings. Now on Windows, I think settings exist under file or edit menus. Okay, regardless, find the settings page. Now up here, search for compiler. Now under build, execution, and deployment, here under compiler, check this box, build project automatically. That's the first setting. There's one more setting we have to modify here. On the top, search for advanced settings. Right here under advanced settings, check this box, allow automake to start even if developed application is currently running. So check this box. All right, now let's restart our application. All right, with this in place, every time we change our code, after a small delay, our application gets restarted. Let's see it in action. So let's go back to our home controller and change index.html to index. Okay, now after a few seconds, our application gets restarted. This is not ideal. It's not as fast as what we have in environments like Node or React. It is what it is, but I thought to cover it in the course because a lot of people use this tool. All right, our application got restarted. So back in the browser, if we refresh, we can see the homepage is broken. So this is the dev tools. Now, I personally am not a fan of this tool. So whenever I make changes, I like to restart the application using Control and R. But going forward, I'm going to check this box so this doesn't get in the way and we can quickly see the result. Now let's change this to index.html and move on to the next lesson. In every application, there are settings we'll need to configure, like which port the application runs on, database credentials, or even custom settings for our application. So let's see how we can configure our application properties. Here in the resources folder, we have this file, application.properties. We briefly talked about this before. Here we have a bunch of key value pairs. Some of them are standard, like spring.application name. we have several standard properties like server.port. The default value is 8080, but we can change it to whatever we want. And this will be the port our application will listen on. Now I'm going to remove that. We can also define custom properties like app.whatever, like page-size. Okay. Now to use these properties in our code, we have to use the value annotation. Let's see how this works. So first we go to our home controller. To do that, we press Shift, Command, and O on Mac or Shift, Control, and O on Windows. Let's go to our home controller. Okay. Now in this controller, we want to define a private field and initialize it with the value of spring.application.name. So let's declare a private field, private string. We can call that app name or whatever. Now we should annotate this with the value annotation. We press enter, so it's imported on the top. It's defined in this package, org.springframework.beans.factory.annotation. Okay. Now, as an argument, we should pass a string with a special syntax. First, we type a $, and inside braces, we type the key of an application property. In this case, I'm going to copy this key, spring.application.name. Now, at runtime, Spring will get the value associated with this key and inject it into our private field. So now to see this in action, we can use a print statement. So system.out.println, and here we can print the application name. Okay, let's rerun our application and refresh the homepage. Okay, now here on the console, look, app name is store. One of the core features of the Spring framework is dependency injection. It's a powerful concept that is used in real-world applications. In this section, we'll start by breaking down what dependency injection is, why it's important, and how it helps make your code cleaner and easier to maintain. You'll learn how to implement it using constructors and setters. We'll then dive into how Spring Boot handles dependency injection using the IoC container. You'll see how to configure beans with annotations, control which beans are selected when multiple options are available, and externalize configurations to make your application more flexible. Finally, we'll explore advanced topics like configuring beans programmatically, using lazy initialization, managing bean scopes, and controlling the lifecycle of your beans. By the end of this section, you'll have a strong understanding of dependency injection and how Spring uses it to manage the components of your application efficiently. Now let's jump in and get started. So what is dependency injection? Many students find this concept confusing or complex, but it's actually very simple. Let's break it down with a real-world example. Imagine we are building an e-commerce application. We have an order service class that handles placing orders. When an order is placed, the customer's payment needs to be processed. So order service depends on a payment service like Stripe Payment Service. In this case, we say order service is dependent on or coupled to Stripe Payment Service. At first glance, this might seem fine, but let's talk about the issues that arise when one class is tightly coupled or dependent on another. The first problem is that order service can only use Stripe Payment Service. If tomorrow we decide to switch to a different payment provider like PayPal, we would have to modify the order service code. And once we change the order service class, it has to be recompiled and retested, which could impact other classes that depend on order service. The second problem is that we cannot test order service in isolation. Because order service is tightly coupled to Stripe Payment Service, we can't test its logic separately from Stripe Payment Service. Now, the problem here isn't that order service depends on Stripe Payment Service. Dependencies are normal in any application. The issue we have here is about how the dependency is created and managed. Let me give you an analogy. Think of a restaurant. A restaurant business needs a chef, right? So there is a dependency between the restaurant and the chef. If the current chef becomes unavailable, the restaurant can hire another chef. This kind of dependency is totally normal. But what if we replace chef with John? That means our restaurant is now dependent on John, a specific chef. What if John becomes unavailable? we can't replace him with someone else, and the restaurant will be in trouble. This is an example of tight or bad coupling. Now, back to our e-commerce application. We don't want order service to be tightly coupled to a specific payment service like Stripe. That's like a restaurant being dependent on a specific chef. Instead, we want order service to depend on a payment service, which could be Stripe, PayPal, or any other provider. To achieve this, we can use an interface to decouple order service from Stripe payment service. An interface in Java is like a contract that defines the capabilities of a class. It doesn't contain any implementation or logic. It simply lists the methods or capabilities a class should have. For example, if order service depends on a payment service interface, it doesn't know anything about Stripe, PayPal, or any other payment provider. As long as these providers implement the payment service interface, they can be used to handle payments, and order service wouldn't care which one is being used. So here are the benefits. If we replace Stripe payment service with PayPal payment service, the order service class is not affected. We don't need to modify or recompile order service. Also, we can test order service in isolation without relying on a specific payment provider like Stripe. Now, with this setup, we just have to give order service a particular implementation of payment service. This is called dependency injection, meaning we'll have to inject a dependency into a class. Just like how we can inject a drug into a body, we can also inject an object into a class. Now, there are a few different ways we can do this, and we're going to cover them over the next few lessons. But first, let's jump into the code and set up our example. All right, back to our project. Here in this package, let's add a new class. We're going to call this order service. Now, let's give it a method, public void place order. Now, in a real application, we should pass an order object here, but let's keep things simple and focus on dependency injection. So no parameters. Now here we need to use a payment service like Stripe. So first, we go back to our project and add another class here, Stripe payment service. Now, in this class, we add a method, public void process payment. Now, in a real application, we should pass a payment object here that encapsulates payment information like credit card details. But again, to keep things simple, let's just add a simple parameter like a double here, double amount. Now, in this method, let's add a print statement. Let's change the message to amount. We just print the amount. And right above that, we add another print statement and say Stripe. Now, in the future, we can create another payment service like PayPal, and in that class, we'll print PayPal, okay? Now, our order service needs to use Stripe payment service. So, back to this method. Here we declare a variable, payment service, and set it to a new instance of Stripe payment service. Then we call payment service dot process payment. Let's hardcode a value like $10, okay? Now, this is our earlier setup before we introduced an interface to decouple these two classes. So in this implementation, the order service class is dependent or tightly coupled to Stripe payment service. So that means we cannot test order service in isolation, because whenever we want to test that, we have to bring in Stripe payment service. And also, if in the future we decide to switch to a different provider like PayPal, we'll have to modify the order service class. As a result of this, the class has to be recompiled, retested, and this can propagate to several other classes in our application. So this is where we use an interface to decouple order service from Stripe payment service. To do that, we go back to our Stripe payment service. On the top, under the refactor menu, go to extract, and then interface. Now, on this dialog box, first we specify our interface name. We're going to use a more general name, so we remove Stripe and just call this payment service. We leave it in the same package, and then down here, we select the method that we want to include in the interface. By default, it's not selected, so make sure to select it, and then click refactor. Now, IntelliJ is saying that this interface has been successfully created. It's asking if you want to proceed. Yes. And then it says, use interface where possible. This is called programming against interfaces, okay? Let's go ahead. Look what happened. Now Stripe Payment Service implements Payment Service. Let's take a look here. So we hold down Command on Mac or Control on Windows and click here. This is our interface. As you can see, this interface has no implementation. There is no logic here, no algorithm. All we have is a method declaration or a capability. This is like a chef that can cook, but how they cook, we don't know. That is dependent on the implementation, okay? Now, with this setup, we have to modify order service. So instead of being coupled to Stripe Payment Service, it should be coupled to Payment Service. We'll do that next. One way and the recommended way to inject a dependency into a class is via a constructor. So here in the order service, let's define a constructor, public order service. We press tab to complete the code. Now we should pass our dependency as an argument to this constructor. So first we give it a parameter of type payment service. We press tab and tab again. So we receive a payment service object here. Now we should store this in a field in this class so we can use it in the place order method. So we can declare a private field, private payment service, tab, and then initialize it in the constructor. IntelliJ automatically detected the code we want to write, so we can just press tab, and here it is. So when creating an order service, we pass a payment service object, we store it in a field in this class, which is declared up here, and then in the place order method, instead of using Stripe Payment Service, we use the payment service object that we have in this class. This is our setup. Now to see this in action, we should go back to our project and go to the store application class. We're going to take a break from Spring, so we're going to comment out this line. So instead of running a Spring application, we're going to run a console application. So here in the main method, first we declare a variable called order service. Then we set it to a new order service. Now here in the constructor, we have to pass a payment service. This is our chance to inject a dependency into the order service class. So we can pass a new Stripe payment service, or in the future, we can pass a different payment service like PayPal, okay? Now we can call order service.place order. Let's run our application. All right, look, we are using Stripe to process $10. Now let's create a new payment service. So in this package, we had a new Java class called PayPal Payment Service. Now here we say this class implements payment service. So we press tab to complete the code. Now we have an error because this class is not implementing the methods declared in this interface. So we can press Alt and Enter. And here we select Implement Methods. In this dialog box, we can see all the methods declared in our payment service interface. By default, this is selected. Otherwise, we have to select it and then we click OK. So here's our implementation. Now to save time, I'm going to go back to our Stripe payment service, copy these two lines and paste them in our PayPal class. We just have to change Stripe to PayPal. Okay. Now with this change, we can go back to our store application. And when creating a new order service, we can give it a new PayPal payment service. Now, if we run the application, we can see that PayPal was used to process $10. But here's the interesting part. As a result of supporting PayPal payments, we didn't have to modify our order service. So we extended our application by creating new classes instead of modifying existing ones. In object-oriented programming, this is called open-closed principle. It's a very important principle in building maintainable software. The open-closed principle says that a class should be open for extension, but closed from modification. In other words, we should be able to add new functionality to a class without changing its existing code. Now, why is this important? Because by avoiding changes to existing code, we can reduce the risk of introducing bugs and breaking other parts of the application. Now, of course, this is just a guideline. It doesn't mean we need to blindly apply it everywhere in our application. Like any principle, it's something we should strive for when it makes sense and adds value. Now, you might have seen people like our famous rockstar developer, Mr. John Smith, who hate object-oriented programming. One reason might be that they read principles like the open-close principle in a book, applied them blindly to every corner of their application, and ended up with an over-engineered mess. And of course, instead of blaming their own misuse of the principles, they blame object-oriented programming itself. The takeaway here is that principles, like the open-close principles, are tools, not rules. They're meant to guide you in building flexible and maintainable software, but you should always use them with common sense. Another way to inject a dependency into a class is via a setter. So here in the order service class, we're going to define a setter for setting the payment service. Now we can type that setter by hand, or we can have IntelliJ generate it for us. First, we put the cursor on the field name. Then we press Command and N on Mac or Control and N on Windows to bring up the Generate context menu. Here we select Setter, Enter, and proceed. All right, here's our new setter. So this setter gets a payment service and sets the payment service field in this class. Now, I don't like that IntelliJ inserts the generated code on the top because by convention, we put getters and setters in the bottom. So let me show you another cool shortcut for moving this code. First, we put the cursor on the method declaration on the first line. Now we hold down Shift and Command on Mac or Shift and Control on Windows. Now, by pressing the down or up arrows, we can move this method around, okay? I'm going to move it to the bottom. So here it is. Now, to use this, we go back to our store application. Here we call order service .set payment service and pass new PayPal payment service. Now, of course, this looks a little bit ugly because we don't want to pass the payment service twice. So it would be better to remove the payment service from constructor and then pass it to the setter. So back to our order service, we can remove or comment out this constructor. The shortcut to do that is Command and / on Mac or Control and / on Windows. Okay? Now back to our store application. We create an order service. We set the payment service and then place the order. Now there's a problem with this code. Can you tell? Here's the problem. What if we forget to set the payment service? Now, if we run our application, it crashes. We have a null pointer exception. So we should use this approach for optional dependencies. In other words, our order service should be able to do its job without having that external dependency. In this case, a payment service is not an optional dependency, it's a required dependency, so it doesn't make sense to inject it via setter. Again, for the most part, constructor injection is the more common and the recommended way to inject dependencies. So far, we have been manually creating a payment service and passing it to order service. While this works for simple examples, it quickly becomes a headache as our application grows. What if PayPal payment service has its own dependencies? We would have to create more objects and wire them together. Managing all of this manually can get messy, tedious, and error-prone. This is where Spring comes to the rescue. One of the core features of the Spring framework is its ability to create objects and inject them into our classes automatically. At the core of the Spring framework, we have what we call an IoC container. We'll talk about IoC in a minute, but this container is responsible for managing the objects in our application. In Spring terminology, we refer to these managed objects as beans. So a bean is just a regular Java object that is managed by a Spring. Spring takes care of creating it, injecting its dependencies, and even managing its lifecycle. Now, what is IoC about? Well, IoC is short for inversion of control. The name comes from the fact that it inverts the control of creating objects and managing dependencies. In a traditional application, we are in control. We write the code to create objects and manage dependencies. But with the IoC container, we hand over that control to Spring. Let's see this in action. So I'm going to bring back this line. Now, this run method returns an object of type application context. application context is our IoC container. It's a storage for our objects. So we can store the result in an object of type application context that is defined in this package org.springframework.context. So we import it and call this object context. Now this context has a method called getBean. With this method, we can get a bean or an object that is managed by a Spring. In this case, we need a bean of type order service, right? So as an argument, we pass order service dot class. Okay, then we store the result in order service. So instead of us manually creating objects and injecting dependencies, we let Spring take care of that for us. So let's remove this line. Okay, now let's run our application. All right, our application crashed with an exception of type no such bean definition exception. The message says no qualifying bean of type order service available. In other words, Spring doesn't know how to create an instance of order service. There are two ways we can solve this issue. We'll talk about them next. There are two ways we can tell Spring about objects it should manage for us. One way is using annotations, and that's what we're going to cover in this lesson. There is another way using code, which we'll look at later in this section. So back to our main method. Look, here we need to get a bean of type order service. So we want Spring to manage objects of type order service. To do that, we go to our order service class and annotate this with an annotation called component. This is defined in org.springframework.stereotype. So let's press enter. So this is imported on the top. Okay. So with the component annotation, we tell Spring to manage objects of type order service. Now, component is a general purpose annotation. We have other specialized annotations like service for classes that contain business logic. We have repository for classes that interact with a database. We have another annotation that you have seen before, and that's controller. This is used for marking classes as controllers for handling web requests. So back to our code, order service is a service class. So here we can also use the service annotation. Now, technically, service is just an alias for the component, so there is really no difference between the two. Let me show you what I mean. So hold down Command on Mac or Control on Windows and click Service. Look at the implementation. Look, service is an alias for component. So we can use either of these annotations, but the component annotation is often used for utility classes. We use service for classes that contain business logic. Now, look down here. We have an error saying could not autowire, no beans of payment service type found. What this error is saying is that order service needs a payment service, but payment service is an interface. So Spring doesn't know how to create instances of the payment service interface. To solve this problem, we have to go to the PayPal payment service class and annotate this with either component or service. Now, technically, we should do the same with the Stripe payment service, but don't do that in this lesson because that's going to cause an issue that we'll talk about later in this section. Okay? So we simply annotated two classes with service. Now, if we run our application, we can see that PayPal was used to process $10. Beautiful. Now, there is another annotation you need to be familiar with, and that is auto-wired. Let's go back to our order service class. So here we have a constructor that takes a payment service. Now, in the past, we had to annotate this constructor with auto-wired to tell Spring to auto-wire this object with its dependencies. But going forward, this is not necessary if our class has a single constructor. So in this case, we can comment this out and everything works, but you might see the auto-wired annotation in a lot of older code bases. Now, if you have multiple constructors here, we have to use auto-wired. Let me show you this in action. So I'm going to temporarily comment this out. Now let's create a default constructor, order service. Now, if we run our application crashes with a null pointer exception because in this example, Spring prefers to use the default constructor with no arguments, and as a result, payment service will remain uninitialized. To solve this problem, we have to bring back the auto-wired annotation. Now, when we run our application, everything works as expected because we have told Spring to auto-wire this class with its dependencies, okay? Now, what if we have another constructor, but not a default constructor? So let's add payment service here and give it a second parameter like int x. It doesn't really matter. Now look what happens if we remove the auto-wired annotation. Right away, we can see an error here saying class doesn't contain matching constructor for auto-wiring. But let's run the application and see the error we get, because that's a very common error in Spring applications. So let's run this one more time. All right, now we got an exception of type bean creation exception. And the message is error creating bean with the name order service. This is a very common exception. So to solve this issue, again, we have to bring auto-wired back. So Spring auto-wires this class with its dependencies. Let's run our application one more time. Problem is solved. So let's remove this other constructor as well as the auto-wired annotation and move on to the next lesson. If you found this useful, imagine what you will learn in my full Spring Boot course. As I said, the full course has 2 parts, with each part about 6 hours long. It covers a whole lot more and is packed with exercises to make you a job-ready developer. Click the link below and start learning today.